Day 403 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 113, Path Sum 2. The difficulty level is medium, but don't worry because we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. Given the root of a binary tree and integer target sum, return the all root to leaf paths where the sum of the node values in the path equals target sum. Each path should be returned as a list of the node values, not node references. A root to leaf path is a path starting from the root and ending at any leaf node. A leaf node is a node with no children. All right, y'all, so that sounds simple enough, but let's go ahead and take a look at these examples anyway, just to make sure that we're doing this problem correctly. So in example 1, we have the input root equals a tree, a binary tree. I think it's so we have we have values 5, 4, 8, 11, null, 13, 4, 7, 2, null, 5, and 1. The target sum is 22. So we want to find all paths starting from this root node to any one of these leaf nodes that have a target that equal our target sum of 22. So it gives us a picture right here showing us the two paths that we can create to get to our target sum, which is 22, which our output is a 2D array. First one being 5, 4, 11, 2. The second one being 5, 8, 4, 5. Explanation says these are two paths whose sum equals the target sum, which is 5 plus 4 is 9, plus 11 is 20, plus 2 is 22. That's our target sum, 22. And we can reach this path right here. We go 5, 4, 11, 22. So when we add up all the nodes in this path right here, they equal our target sum of 22. Also, we have another path right here that equals our target sum, 22. 5 plus 8 is 13, plus 4 is 17, plus 5 is 22. And that's this path over here. We got 5, 8, 4, and 5. And when we add up all of these nodes, we get our target sum of 22 as well. So we return both of the paths in a 2D array. Boom. So let's look at example 2 where they give us a trick question where it's impossible to reach our target sum. So in example 2, we have the input root equals an array or binary tree 1, 2, and 3. The target sum is 5. The output is a blank array or blank tree because it's impossible for us to reach our target sum. We could do 1 plus 3, that'll give us 4, or we could do 1 plus 2, that'll give us 3. Neither one of those paths equal up to 5, so we just return a blank array instead. Similarly, in example 3, it's pretty much similar or the same as example 2, where it's impossible to reach our target sum. So in example 3, we have our input root equals the binary tree 1 and 2. Target sum is 0. The output is a blank array because with this binary tree right here, it's impossible for us to get our target sum of 0. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution, y'all. Solution is not that difficult at all, so let's get into it. The first thing we're going to do is we are going to define a nested helper function for our depth first search traversal. So we're going to be using depth first search, and we need a nested helper function. So for that, we could say inside this main function, we're going to create another function. We could call it DFS for depth first search. We're going to open up the parentheses, underscore. It's going to have a node. Then we're going to say colon. That's going to be a tree node. And we're going to put a question mark at the end. Boom. Now we're going to open up our brackets. And we're going to create a base case. If the current node is nil, then we can return or stop the recursion. So we're going to say guard let node equals node, else we can open up the brackets and we could just return like that. Boom. Then we're going to add the current node's value to the running sum. So for that, we'll just say sum plus equals node dot val, and that's going to give us the value of the node. Then we're going to add the current node's value to the current path. So we're going to say cur dot append. We're going to open up the parentheses and pass in the node dot val. Boom. Now, if the current path sum equals the target sum and the current node is a leaf node, which means it has no left or right child, then we found a valid path and we can add it to the result. So for that, we come underneath this and we say if sum equals target sum, then, and two and signs, because we need to make sure it's a leaf node. We're going to say node dot left equals nil, and two and signs, node dot right equals nil. Then we can open up the brackets and we can say ands dot append, open up the parentheses and pass in cur. Boom. Now we need to recursively explore the left subtree. So we're going to come underneath this and we're going to say DFS, open up parentheses, node dot left. Then we need to do the same thing for the right and recursively explore the right subtree. So we're going to come underneath this and we're going to say DFS, open up the parentheses, and we're going to say node dot right. Boom. Now we need to backtrack and remove the current node's value from the sum path. So for that, we come underneath this. We say sum minus equals node dot val. Come underneath that and we say cur dot remove last, put the parentheses like that. Then we come underneath that and we can just say return. Boom. Now that's it for our helper function. Now we need to initialize variables, and the first one we're going to initialize will be ands, which will store our output or the valid paths that we have found. So for that, we come outside of this helper function and we declare a variable called ands. I'm going to set that equal to a 2D array of integers, like this. So square bracket, and inside, because as you can see, our output is a 2D array of integers. So this ands is where we're going to store output. And then we could just put parentheses right here outside. Then cur is going to store the current path of nodes being explored. So we come right here, declare a variable called cur, and we're going to set that equal to an array of integers. Come over here and put the parentheses like that. Boom. Now we're not done yet. Still have a few more variables. We need the sum, which is going to keep track of the sum of the current path. So we come underneath this, declare a variable called sum. We can set that equal to 0. Boom. Then we need to start our DFS traversal from the root node. So we're going to say DFS, open up the parentheses and pass in root. And then we come underneath that and we just need to return all valid paths that we have found, meaning we need to return ands right here. So sorry y'all. So we come right here and we just say return ands, just like that, y'all. Now that should be all that she wrote. Let's go ahead and give it a run, make sure it runs properly before we submit it. And it's accepted, y'all. So let's go ahead and submit it. See what it looks like after we submit it. Make sure it still works when we submit it. And look at that, y'all. 0 milliseconds means 100% of users. That's what I'm talking about. Those are the numbers I like to see. So with that being said, y'all, make sure you get one more look at the code. This is the top part with the nested function. Come down. This is the bottom part. This is the rest of the code. And yeah, read it, learn it, love it. And with that being said, y'all, I hope y'all learned something today. And I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.